Hello, my name is Vlad. I'm happy to see you on this channel. Today we will talk about the fundamentals of manual QA activities. The next information will be the most relevant for people who has no experience in manual QA industry or has some limited experience there. We will talk about the next topics like testing, quality control, quality assurance, software testing lifecycle, and software development lifecycle. Also, I want to touch such items like quality and its attributes. And the most important for the manual QA, it's the main test types, test design techniques, also test levels and test documentation. I hope that you find IT like the most relevant and most important skyrocketing industry that you want to join. I'm happy to be your guide here and welcome on board. If you will follow all the video, you will find out the most important information that will allow you to get your first junior manual QA position. And I wish you good luck here. So, manual QA theory. Here we can see our agenda, we talked about it earlier. And the first slide, but before I want to make a small announcement. At the end of this video I prepared small table with main QA terms for you. I think it will help you to make your learning process easier and more clear. So all the details how to get access to this table are at the end of this video. And let's get back to our slide. So here we can see the answer for the next question. Why quality assurance is needed? So, each product or service should be tested before the release to the real clients or customers. It allows us to avoid such cases when the pit is able to destroy car completely, or children's slides injure kids, or for example subway car can open the doors while the train is moving and it can cause the death of the passenger. Also, there are some more cases which are presented on this slide. So, if we will summarize, quality assurance activities helps us to control product quality, identify issues, escalate issues, and also verify issues by the process of the creation and running test cases to verify actual result which should meet requirements and user expectations. So, it's the main idea of this slide. Let's get to the next. So let's figure out what activities tester is responsible for. To make it we need only three terms. So the first one and the most basic is the testing, specific research that we make to provide information about the software quality. We do not escalate issues that were detected during these executions, but we deliver the test report which indicate the pass tests and the fail tests. Quality control is the next term, which is also very important. Here we need to run tests, detect issues, escalate them for fix, and also verify that fix was actually made. Also, we need to make sure that we paid attention for the backward compatibility. It allows us to avoid such cases when the new feature or the fix process used to damage existing functionality. So also very important. And the most advanced level is the quality assurance. It's a process-oriented, prevention-based activity which is focused on the management side. Here we can establish, for example, some kind of the specific flow with the code review, which will be able to decrease amount of the bugs during a development process, or for example some code conventions, and also some more activities. What you need to know: quality assurance include quality control and testing, like the one group of the terms, yes. And quality assurance is the most important, the most advanced level, and testing it's the most basic level of this term. So that's the main information for you. And let's go next. Software development lifecycle. If we are going to test software products, we need to know how such products are created and what stages they pass. SDLC diagram is the best evidence that allows us to understand it. I will try to go over each stage of the SDLC and make some abstract examples. It will allow you to understand all process. So, SDLC consists of requirement analysis, design, implementation. The most important for us is testing, because we are QAs, yes, and also the evolution process. Let's try to assume that our abstract example is the YouTube creation process, yes. So we decided to create such service like YouTube. requirement analysis stage for the YouTube is the next. We need to identify problem. So for example, I, like the user, want to choose videos by content, by type, by topics, by authors, and so on. Yes, unfortunately I can't control TV either, so it looks like the YouTube idea is very perspective and very promising. After that, I need to make the market research. So, for example, there are some other companies which used to implement this idea and successfully sell their services. So, there is no need to make the duplication of the service. And let's assume that our market is absolutely clear. Nobody used to make such service like we want. Yes. After that, we go to the next stage, which is design. So, here we need to establish the text requirements. After that, we can make the mockups, we can hire the design team, which will provide us the really detailed, really nice, user-friendly graphic user interfaces, yes. Also, we can hire, for example, some financial team, which will make the budgets for us. Also, we can make the development roadmap here, yes. We can indicate time frames which we want to implement the idea and so on. Yes. After that, we have the stage which is implementation. So what is done here? We need to hire the development and other teams. Yes. And to make the implementation of the idea. So developers will write the code. Marketing will make some kind of activities that will allow us to get clients. QAs will try to test something and so on. Yes, so it's the implementation stage. After the first product is created, the first version of product, we are going to test it. So it's the most important for us, like the QAs. We need to perform all the QA activities to ensure that product meets requirements and customer expectations. Here we detect some kind of bugs, we escalate them and we fix them. After that, we have the next stage, which is evolution. So what does it mean? We used to add some new features to our product, enhance it completely, and go to the next level of our improvement. Yes, so we delivered better results, better user customer satisfaction to our clients. So I think that it's the most relevant information about the software development lifecycle for the QA persons. And let's go next. Quality. In previous slides, we touched such term like quality quite often. All test job is focused on quality, and it's very important to identify what actually it is. So, all test job is focused on the quality and its verification, by the way. The term of quality is the next. It's the degree to which component, system or process meets requirements or customer expectations. By this term, it's hard to understand what actually quality is, yes, but let's try to focus on examples. I think that we need to avoid software example at the very beginning, and let's focus on life example. So, let's assume that we have the product car. Yes, one product which is car, but we have different types of products. For example, truck and the sport car. So quality and its attributes for truck and quality and its attributes for sport car are completely different. Yes, I will try to make some examples. So for truck, it's very important the load capacity. It's very important to have some kind of easy cleaning interior. It's also important to have a nice dimensions, because we need to be sure that car size is applicable, is suitable for depot. Yeah. About the sport car, what do we need here? What quality we expect here? It's some kind of the color, comfort, speed. It's very important for the sport car, yes. But for truck speed, it's not the most important what can be. Design also, interior and exterior design for sport car, it's quite important attribute also. So let's get back to the software and let's focus on the software quality. There are established 8 software qualities by International Organization for Standardization. So, functional suitability. All features, all functionality is completed and correct. Performance. For example, we have the web page, so it should load fast. Client is not able to wait several minutes for the page to be loaded. After that, compatibility. So the software do not affect negatively for other soft which is installed on our machine. The next one is usability. So a user-friendly interface, intuitively understandable scenarios and flows. After that, we have something that is reliability. So if we have some failures in our software that used to be occurred, yes, or some unexpected cases happened, yes, we need to understand how our system will recover, if everything will be okay or not. Security, very sensitive part of the quality, yes. All user data should be protected. For example, it's very bad when Google index our payment information and it's possible to see this information in search results. Or for example, somebody used to steal information from the internet shop about your payment details and so on. So it's very sensitive kind of quality, and it's very important to test it also. The next one is maintainability. How easy we can deliver updates to our clients, how we can test some analytics, some metrics from users and so on. And portability, it allows us to understand how easy the software is able to be installed, uninstalled, replaced and so on. So a little bit more information about these software qualities and their attributes you can find on the ISO webpage. The link is inside of the presentation. And the most important, so a scope of applicable to test quality attributes is determined by each product. So you don't need to apply each of these qualities and its attributes to your product, because for example security is not applicable for the projects which has no sensitive data. Yes, for example, if you have if you develop the calendar and it doesn't use some kind of sensitive data, so it's not applicable in your case. Yes, and also each task that you assign to also identifies what are the expectations of the stakeholders and other interested people in the test activities. So you will have the instructions for there about what actually you need to test. So let's go next. STLC, Software Testing Lifecycle. As you remember, in previous slides we had the diagram of the software development lifecycle, and there exists the testing stage. So what is inside of the testing stage? Let's try to identify. If we want to test software, we need to know how the test stages are set, yes, and what is inside of our QA workflow. So software testing lifecycle consists of test planning, test design, test execution, defect reporting and defect verification. So test planning, what is it? It's the process when you when you have the assigned task and you have some kind of purpose. Please test some kind of the feature. Yeah, you need to request the requirements. You need to evaluate them and you need to make your proposal about the terms that you need to finish this task, about the test design techniques that are applicable for this purpose, and so on. If you have no requirements at the test planning stage, please do not continue with the next stages, because you will waste your time. Inside of the requirements there is the core of expected result, which you will use in your test cases. If you will skip this stage and skip this information, so you won't be able to create efficient test design, and it's the waste of the time, and it's actually the mess. So please do not start without requirements. The first action you need to make at the test planning, it's to request access to the requirements. After that, the test design process. What is it? So you create all kind of the test documentation. Everything starts with the test plan. After that, we create test cases, group them in test sets, and create the test executions. So it means like the basic test documentation should be created at the test design stage. Also, all of this documentation should be approved by the stakeholder, and after that you can continue to the next stage. It's the test execution. on test execution, you are running that tests that you used to create at the test design stage. And here you will have some kind of test that used to be successfully passed, so actual and expected result will be the same. And also you will have some kind of other situation when actual result won't correspond to the expected result. So it means that you will indicate a bug, you will detect some bug. So here we used to go to the next stage, which is defect reporting. So when actual and expected result do not correspond, they are different, it means that we have an issue, that we have defect. So we need to create the bug report for this purpose, and inside of defect reporting we make such action. After that we need to escalate it. When we escalated it to the product owner, to the stakeholder, he transferred this specific ticket, I mean bug report, to the proper developer, which make the fix process. We are going to the next stage, which is called defect verification. So after the time when developer used to fix the escalated issue, we need to verify if this issue was actually fixed completely. Yes. Also, we need to identify if maybe some kind of additional issues were added during the fix process. Maybe backward compatibility is not good for us, yes, because some kind of features that used to exist previously, they became damaged due to our changes. So we need to think also about it. It's very important. And I think that this software testing lifecycle, it's the basis, it's the most important information that you need to know, and it's applicable for each task that you will be assigned to. So you get the task, you follow all of these stages, and it will allow you to be efficient and professional QA. So let's go to the next slide. Project requirements. So we have 3 layers of requirements in software. Let's try to assume that we have the same abstract example that was in previous slides, like YouTube creation, yes? And for example, for business requirements for YouTube creation, we can say that we, like the business, we create YouTube platform for specific business model, which consists in selling of advertising and selling of the memberships or subscriptions to some kind of the content that is available on YouTube. Yes? Yes. So the next one, it's the user requirements. Yes. So we identify the user needs, the user expectations, user input, output. Yes. And we create the sitemap of user needs. Yes, so for example, user need to be able to watch video, user need to be able to upload the video, user need to be able to delete the video. Yes, it depends of the user roles, but actually it's the user needs. Yes, so the next one, it's the system requirement layer, the 3rd layer. It allows us to establish all needed for a work of our software that we are going to develop. In our case, it's the YouTube platform. Yes, so it means that we need to have the connection to the internet, specific software, which is operating system. Yes, Windows, Mac, Linux, or something else. Also, we need to have some kind of vCPU, of memory, and some kind of additional resources on our local machine that we will use to work, to interact with the software that we are going to develop. In our case, it's YouTube platform. So the main type of requirements that junior QA will work, it's the user story. It's very interesting requirement. It consists of three strings, yes, and the first one indicate the user, the second one indicate the task, and the last one indicate the result. So as you can see from this this example, I will try to apply this example to our YouTube platform. So as user in blogger role, yes, I want to be able to upload videos to internet so that it will be available for watch to public all over the world. Yes, so it's some kind of example of the user story that you will work with. User story and documentation, whole documentation should be fully covered per each feature. Yes, so there should be no gaps with the functionality that we are going to implement. So each feature that is implemented, it should have some kind of requirements per it. Yes. After that, I want to indicate that documentation should be sharp and clear, no inconsistencies, no ambivalence, no gaps. It should be very, very sharp and clear to let you know what actually to test and to let developers know what actually to implement. Also, if we have some kind of specific terms, if our software makes specific terms, we need to add the glossary to define these terms, so they will be understandable for people who will work with this documentation. So let's go next. Test types. Congratulations to you, we reached the most important part of our lesson, so pay attention. There are two main test types, especially for the beginners. They are called black box and white box. You will use black box mandatory during several years of your experience. White box will be used after the great progress and after several years of your career in quality assurance. So let's focus on the black box, but also let's try to identify the differences between those two terms. So black box, it's the approach when a tester is not familiar with the internal implementation of the feature. So code structure, interfaces, classes, functions that are triggered during scenario, they are not visible, they are not applicable to a tester. Yes, so he is not familiar with all of this information. Actually, the person who performs quality assurance activities with the black box, this person can have zero background in programming. About the white box, so it's absolutely opposite to black box. So quality assurance activities are performed with the tester who know how the feature is implemented. So he know internal implementation, structure of the code, he has access to it, he is able to understand how output is generated and can test internal points that are not visible to a regular customer, but they affect such customer. Important to understand that black box test type consists of test design techniques. So the next test design techniques are included in black box test type. So equivalence classes, boundary values, decision table, pairwise, state transition, domain analysis, and use case. All of them we will cover in the next slides. Test design techniques, and the first one is equivalence classes. Let's try to find out why do we need test design techniques and what are the benefits of using them. So, test design techniques allow us to reduce number of tests without negative impact on the quality of our test activities, and as a result we are able to deliver our test results faster and we are more efficient. Yes, so it's very powerful a tool in our hands that we need to use. About the equivalence classes, let's try to figure out what actually is it. So it's a set of values, full execution of which can cause the same output. So output doesn't change at the old range of these test values. Yes, and also it do not lead to the discovery of new issues, of the new defects that are possible to find. So what does it actually mean? Yes, let's try to identify it on this kind of example. So from the left side you can see the table which is the requirement table for insurance app. Yes, for example, we want to sell insurance for male and female. It's the gender criteria for three main age types. Yes, up to 20 years, up to 50 years, and up to 100 years. Let's try to identify equivalence class for one of items inside of this table. So Let's try to figure out the most important for male, which are up to 20 years. So the equivalence class for male up to 20 years will be the next one. So all values from 1 to 20 are the equivalence class for male. Because why is it? Because the output for all values inside of this range is the same. Output is absolutely the same. We expect that we will get 10 United States dollars. Yes, and we are probably not able to detect some kind of additional issues. Yes, if a whole equivalence class doesn't work, so we need to verify it only with one value. So one value, for example, value 5, will be enough to test whole equivalence class. If we will get in output like 10 United States dollars for such client, it means that our equivalence class work. So all of another values at the range from 1 to 20, they are correct. Yes, but to identify the correctness at the ranges, at the edges of this range, we will need another one technique. I will show you a little bit later. But right now, let's assume that the situation is like I used to describe. Yes, and let's try to see the benefits of equivalence classes. Yes, for example, when we have no equivalence classes used in our test design, so in total to test this table we will need 200 tests. It's quite a lot. But if we will use equivalence class, we need only 6 test cases. Yes, because we have 3 age types, yes, and 2 gender criteria. So there is enough only one value inside of the equivalence class to be sure that equivalence class works or it doesn't work. Yes, and we are able to escalate like issue in this item. So let's summarize once more. Equivalence class is a set of values, full execution of which do not lead us to the discovery of the new issues, new defects. Yes, and also we expect the same output for all items inside of this equivalence class. So I think that it's the most relevant information about the equivalence classes, and I hope that it will be useful in your practical tasks that you will have soon. Boundary values, second technique we will talk about. We continue to use insurance table from previous slide, and what do we need to know here? So boundary values, it's the test design technique that allow us to find the equivalence class boundaries and test them. It allows to identify start and stop points of equivalence class effect, and also we can say that boundary values consist of 2 types: internal, which are inside of equivalence class that we test, and external, that do not belong to equivalence class that we test. Often these values can be a part of other equivalence classes that we are going to test in the future. Yes, so in this case, such boundaries are applicable. Let's go next. Decision table, other test design technique that allow us to build the tabular representation of the scenarios. It consists of 3 main items: condition, rule, and output. Also, we have true-false criteria to identify user actions and outputs. Tabular representation allows us to identify all possible cases and not to miss important scenarios. So it's a very powerful tool that you are able to use also. Pairwise, interesting, powerful, but quite complicated test design technique. Why complicated, you will ask me? Actually, it's a little bit hard to apply this technique to the big data scope, I mean big test data scope. Everything starts from the IBM research, which was made, and this company found that 97% of software issues are caused by interaction only of 2 params. So, failures in general are caused by not the complicated several params combinations. Often the core of failures is inside only 2 params. So, about the term, about the definition. Pairwise, it's the technique when each test value of each of the checked parameters is at least once combined with each tested values of all the other checked parameters. So, to understand this information, I will suggest to focus your attention on the table from the left side of the screen. Here you can see the specific requirements for the application which used to sell laptops. So it's something like the wizard, yes? Here we have three checked parameters. From our definition, we have here the term which is checked parameters, yes? Let's try to identify what are the checked parameters in this abstract example. So, three checked parameters are operating system, memory, and color. Inside each of these checked parameters, we have two values. It means like test values. From our definition, we can say that we have two test values for each checked parameters. So, to test all possible combinations here, we need in total 8 test cases. So, 2 multiply 2 and multiply 2, it means like that in total we will need 8. Quite easy, absolutely agree. But if we will have not 2 test values for each checked parameters, but for example 100. So 100 multiply 100 and multiply 100 more. So in total we'll have 1 million test cases. To perform such great amount of test activities, it will be quite hard. Also during the execution there will be a lot of human mistakes. Yes, because it's some kind of the combinatorial tests, and it's very easy to make some kind of mistakes there. So to avoid such kind of situations, we need to use the Pairwise. Pairwise is able to decrease total amount of test cases up to 50%. So, for example, in this abstract wizard, which is created for laptop selling, yes, we have in total 8 test cases. But how to decrease this amount? So, from the left side you can see all pairs that are needed to be tested here. Yeah. And from the right side we can see the optimized amount of the test cases with the Pairwise test design technique. So in total we will need only 4 test cases for our Pairwise approach, yes? So why do we need it? Let's try to check once more our definition of the Pairwise test design technique. So each test value, let's make a stop here. Each test value in our example, what is it? It's operating system, it's memory, and it's color. Inside of these params we have test values. Yes? So for operating system it will be Mac and Windows. For memory it will be 250 and 1000, and for color it will be white and black. So each test value, let's focus for example at the very beginning on the first column, which is operating system. So Mac and Windows, yes? So each test value of each check parameters is at least once combined with each tested values of all other test parameters. So if we will focus firstly on the first column, which is operating system, and we have Mac here, so we are interested to combine this Mac with all tested values of other checked parameters, and we have 2 checked parameters others, memory and color. In memory 250 and 1000, and in color we have black and white. So there's enough only to test these unique combinations. So Mac we used to combine with 250 at the first case, yes, and at the 4 case we used to indicate the combination of Mac and the memory value, which is 1000. Also black and white is also combined at the 3rd level of our dependencies, yes. With the red color there are indicated tests that are not applicable for Pairwise because they duplicate our activities. So we do not find any additional issues if we will run these test cases. So in general you can see all the power of this test design technique, all what you need to know about it. So for big scope of the test data we use automated approach, and the link for these automated tools are what is presented inside of the previous slide. Let's go next. State transition. This technique delivers the visual representation of system logic and focus on the state changes and their reason. It allows us to understand the system behavior and create efficient test design. let's understand the main. What does it mean to use state transition? So, first item, we need to analyze requirements and create state transition schema. On this slide you can see such schema for ATM or cash machine. The schema consists of several states. So the first one is default. Yes, card insert or start. It means like the first state that allow us to interact with the system. After that we have active state. In active state there can be a lot of substates like active after several attempts. Yes, you can see 1, 2 and third. Also some other examples. Also we can see inactive. So in the negative scenarios the system can eat card when pin code was not okay. Yes. Also we can focus on the other kind of state which is done or positive scenario when we used to insert the right pin code and get access to account and we are able to perform some other scenarios. So the main idea of state transition is to break down created schema into test cases and run them. So it's the most valuable use case how you can try to interact with the state transition and use it for your efficient test designs and test procedures. Domain analysis. Information that you should know about this test design technique. The first, analyze range of all applicable test values and identify subranges there. Second, pay attention for logical and technical dependencies. The third, try to find risky points at the boundaries of your equivalence classes and inside them. I hope that you remember about our first example with insurance application. Let's imagine that we collect data from our users by input field. So users need to indicate their age with integer number inside of the field. From the left side there's presented the requirement table which you are familiar with from the first slides. Yes, and I suggest to take a look for the test cases which were created with the domain analysis test design technique for this particular case. Everything starts with the valid value. I suggest to start with the integer which is 50, for example, to identify that our system works. For example, internal boundaries for all age groups like 1 and 100. After that I want to test the invalid inputs. External boundaries like 0 and 101. Also, I think that we should pay attention for the negative numbers because age of the user is not able to be negative. Yes, minus 15 I think it's the best suitable value to test this activity. Also, there should be all another numbers, so it shouldn't be like the default minus 15. Yes, in your case. After that, I think we should pay attention for also negative cases which are related to the fraction or the float. For example, 5.5. Our age is not able to be like this because we in the requirements there is indicated that we collect only integer numbers. Also, we can test some kind of math operations. For example, 90 plus 1. Because age cannot be like the math operation. It should be only one value which should be integer. So math operations also are not applicable here, and it's a good test to check. I want to indicate that in math there are presented some letter numbers like E in this case. This the representation of E is 2.7 and a little bit more. So it's also quite interesting case that we need to check. So let's summarize what we used to learn about domain analysis. It's a deep dive into input values. Something that is so uniform at the first glance gets quite different after such analysis. Let's go next. Use case. Technique that create table to indicate the interaction between user and system. It's based on requirements and cover the whole system per transaction, with focus on users' actions. Each table consists of main scenario, steps and their description. Subject who performs step is indicated by letters A or S, so it means like actor or user, yes, and system like the system under the test. Also important to indicate extensions, negative cases or opposite scenarios to the main. Here you can see on the slide the use case for the mobile phone unlock process. The technique allows us to create end-to-end test for the whole scenario or make a detailed test per each step. This technique is very easy and clear to use, so I suggest to work with it. Test levels. Here we can establish the depth of our tests. We have 4 main layers like unit, integration, system and acceptance. Unit is the smallest one, and acceptance and system they are the fullest, the biggest one. So unit, you can find a lot of information about unit. In general, it means like a developer when used to develop a new feature, he create the test for his new feature, yes? But I'm not able to agree with this term because manual QAs also used to run unit tests. For example, when we get tasked to perform test activities over one individual model, for example, chat button, yes? It's something like unit test because we test individual component, individual model. So it's not with the automated approach, not with code, it's manually, but also it's still unit test. After that, we talk about integration. So it means group or several models. What it can be? Let's try to assume that we create the new feature, new functional feature. For this feature, we have front end and back end. Front end, it's the specific layout, so HTML, CSS, and JavaScript. And from the backend side, it's specific kind of new interface, new Java interface, new class, and so on. Yes, and we want to verify how good both these components, front end and back end, are combined. So we create some kind of the new API calls to trigger this function, yes, from the UI. And we want to verify how it works, so it's something about integration test. System, when we need to test all integrated system, all models. Acceptance, the final test, the most important test, which we used to perform before the release to public, before release to client or production. So it's one of the most important test levels. Test documentation. Now I want to show you the main documents that you will need to create on your work. So test plan, test case, test set or test suite, checklist and bug report. So let's try to identify the definition of all of these terms. So let's start with the test plan. Test plan is the basic document that you need to create when you get the new test task assigned on you. So you define the test purpose there. For example, test systems functionality, test systems performance, test systems security. It will affect the test design process and actual test cases that you will need to create for these needs. Also, we need to indicate product requirements like user stories or, for example, PRD, yes, required test design techniques, glossary if it's needed, if it's applicable to your test plan, also test levels and estimation. I think that you need to estimate only your test activities. So it means like test design and test execution. Do not estimate something that is related with the fixed process, because at the point of planning you are not able to understand how many bugs you will catch and how long it will take for developers to fix these issues. Also, you must connect or link to your test plan test cases that you create or checklists if such exist. Also test sets if such were created, and test execution ticket. After that, test case. Test case is the second very important document that we need to create. In your job, in your experience, I think it will be the most popular document that you will create, because the quantity of the test cases is really high in QA job, yes. So it's the set of action and data that we need to perform to verify expected result. So it means like the scenario that should be performed to test something. Test case consists of test action, test data, and expected result. Also, we indicate evidence at the end of each step. So it can be screenshot, it can be a small video, or it can be some kind of file example, yes. So maybe system is going to generate some report and we indicate some kind of report example. Yes, it's very unique thing what you need to add in evidence, but it's very good practice when you add evidence, because it's the most important information for the next people who will run these tests and who didn't created them. Yes, so evidence is very nice, and it must to be. So after that, test sets or test suites. Test suites, it means like the variety of naming. Yes, test set and test suite is the same. So it's the list of the test cases grouped with common purpose when the post condition of first is used as the precondition of the second. So what does it mean? For example, we have the login and logout test cases. So we have two test cases, they are separate. One for login and the second for logout. For example, for logout process, previously we need to be logged in, because without login, logout is impossible, yes? And for example, such two cases we're able to group in the test set. There are more cases when we are able to group, more examples, I mean, when we are able to group test cases in test sets, but I hope that it was enough for you to understand what do I mean. After that, checklists. Checklist is used often when we have limited time frames and when we are not able to invest a lot of time into the test design process. So we create only titles of the test cases without test steps, without test data, without expected result, and without evidence. So how the checklist look? Yes, for example, verify checkout button, verify login, verify logout, and so on. So it means like we have only titles. We do not have some advanced details inside of this checklist, only titles. It's not the best approach. It's not the way to deliver the greatest quality, but it's the possibility to check something in really short terms. So it also can be quite often used. And one of the very exciting documents that we will create, yes, it's the bug report. So it's the document that explains the difference between actual and expected result. So you used to run your test case or, for example, checklist, yes, and actual result was different from result that you expected. So you define this difference like issue, like bug, and you indicate this issue inside of specific ticket or specific document, which is called bug report. Bug report consists of test steps, actual and expected result, yes. Also, we need to add some evidence there. QA is able to indicate the technical effect of this bug on the system. It means like severity. But a product is able to indicate the business effect of the issue on the system. It's like priority. It defines how quickly the issue will be fixed. So, right now, practical task. I think that you need to get the hands-on experience of using the test design techniques that I used to explain you in previous slides, yes? And to make it, I suggest to perform the practical task. You can see the requirements in this slide. So let's assume that we work in automotive company, in IT department of this company, and for example, we have some kind of button inside of car in the interior that is able to be active and inactive. Yes. So the active criteria. The button is able to be active only when doors of the car are closed and the speed of the car is 0. So, what I suggest you to make, please analyze this requirement and try to create the test design for this button. Please make it accurate, clear and organized, and publish the result inside of the comment under this video. I will take care of it, I will look it, and I will indicate your good points or maybe your mistakes when you used to make this kind of test. Now about tips. If you feel frustrated with your new test task, you feel like you are not able to make it, no worry, please do not be so disappointed. It's absolutely normal. It means that you have no enough experience to proceed with such advanced tasks. And what do I suggest to do in such cases? Is to learn more, try to explore the new information, the new books, the new experts in this industry. Simulate and guess. Try to play with the system. Try to take control over it. Try to understand it. And after that, look for others. Try to get some kind of already existing test cases, frameworks, for example, manual frameworks, which explain how to test each of the scenarios. This will allow you to proceed, to find the proper way how to proceed with your task. Also, you can contact me in any possible way, with email, with LinkedIn, with Facebook, or something other, and I will try to help you and answer for your questions. At the end of this video, I want to ask you, please try to subscribe to my YouTube channel. You will find a lot of interesting videos for QA purpose very soon. Also, subscribe to QA group, which I used to create in Facebook. It will be our internal community where you will be able to ask questions, get some kind of answers, and also we will share experience there. And I want to ask you to add me on LinkedIn if it is possible. Also, link is under the video in description. About gift, how to get the table with main QA terms, and it's the most relevant information that will be asked on interview stages for manual QA positions. So, to get access to this table, you need to be a subscriber of the Quality Assurance group in Facebook, which I used to talk about a few seconds ago, and try to send me the message in direct messages in Facebook to request access for this table. I will send you the confirmation. So, thank you for this time, thank you for attention to me. Please indicate like for this video, and see you soon.